Okay, for the first question is asking us about the physical interruption and interpretation. So we say the slope of the volume time curve is the flow rate at time t. So we have liters over second. The flow rate is liters per second. So next question is asking about the VC, which will be volume curve. Its total volume is the air which is expelled from the lungs during the exhalation. And part B is asking about the slope of the flow volume curve. So flow volume curve is right here, the graph, and this is the curve. So it's we decided that the slope of this flow volume curve is the rate of change in the flow rate after V liters of air have been expelled from lungs, and this graph shows you exactly that it's inhaled and exhaled. For the next one,
so for part you should this already?
Yeah.
Okay, so for B part 2, the slope is very positive for the first half of the liter or so, like right here. And then the slope rapidly levels out over 1 liter of exhalation. So right here it just goes level. As the liters exhaled go from 1 to 2, the slope of the curve becomes more negative. So it's going down here. Then as V goes from 2 to 2.5, the slope starts to become less negative. So from right here. This means that the flow rate was increasing very quickly at first, right here. Then reached a maximum at 1 liter. After 1 liter has been expelled, and then the flow rate decreased more and more rapidly between 1 and 2 liters of exhalation, and then decreased less and less rapidly between 2 and 5.5 liters of exhalation. So this is the curve. And then for B part 4, the volume of air expelled when the flow rate reached its maximum was 1 liter. The maximum flow rate was about 11 liters per second. This is identified in our figure graph right here at the largest dV dt value in the graph. And it is identified in the curve from part 3 above this graph, which is the point at which the graph passes through the horizontal axis.
For part C, a patient with asthma may have a smaller VC and a lower peak expiratory flow. The slopes of the flow volume curve would probably not change as quickly. As an example, you can see from the first graph that the curve is more gradual, and then on the second you see that the curve, it goes up and down quicker.